Good morning and welcome to this probably final tutorial of this module. Um, we have come so far and we have learned so much in the last couple of weeks. And just to round this all up, I would like to show you how to select your top three areas. So, as you may remember from the last tutorial, we're looking for a nice place for Swampy to live. Um, and we've this is the same model still as what we were working on. We've built up over time. Naturally, for yours, it's going to be way larger as you have more criteria that you're working with. For me, I'm just going to stick to the two for now, and we're going to have a look. I've done some renaming. We've unioned our criteria, so we've got the combined criteria here. We've added our field, which is some swampy water suitability. We've calculated said field, in which we added swampy suitability and water suitability, and that together has added up to a score ranging from 0 to 2. Um, and if we look at the result, which is this combined criteria here, we have these four different polygons, and I'll just show them on the map. Four different polygons of the 0 suitability, the red. Then we have two polygons of the 1, so the yellow in our map, one being water suitability, the other being swamp suitability, and then of course we have the green, which is our highest rate of suitability, scored at 2. Now, if we're going to talk about top three areas, we need to know several things, and we always said that area size is not a valid criterion to use in your analysis, as it is a result of your analysis. Only once we know what size of area is available, we can choose on what size is acceptable for us. Now, talking about sizes, um, I'll go to the top area. As we can see here, there's different polygons. We've got one over here, we've got two over here, we've got several over here, and these are all very small areas in this case. But I'm just going to go, Swampy doesn't need a lot of space, so we're just going to go with these small areas for now. Okay, combined all of this, it's 92,000, or let's go about 93,000 by approximation square meters. I cannot select a top area based on this because I don't know how big, say for instance, this area is. Okay, so it needs a little bit more doing. And as you might have seen in the example model on page 55, I believe, in chapter 4, there's a tool called multi-part to single part. And we use that to basically, it's in layman's terms, it's dissolve flipped. So basically, it's a backwards dissolve. So once we do that, we run that tool. I'm just going to show, we've named it individual areas, and I've added it to the model or to the display already. And what happens is as soon as we go into the attribute table of this, instead of having, as you can see here, 4 polygons, we go to the attribute table, now we have 194 polygons. There we go. Now we can actually select all the areas that we think are suitable, but we can also see how big they actually are. So now we can go through this and we can scroll and we see all these zeros first, and then we see ones coming up, and then we see, oh, there we go, there's 2's here, and there's quite a few 2's. But there's an easier way to filter on the value of 2. And to do so is simply using the select tool. And now, if you already know what the minimum area size is that your area requires, say for instance for I don't know, if you're doing windmills and perhaps you need 50 square or 50 hectares of suitable land use, then you can filter that in, or you can add that into your select. But I'm not going to do that just yet. I want to have some insight. I want to see some of the information first. So we're going to add select, and we're going to do most suitable areas. We're just going to go most suitable areas. We're going to go into the expression, and swampy water suitability is, I'm going to go to the highest value, number 2. Verify it just to double check that we don't have any faults in our expression. Click OK, and we'll go ahead and run that. Okay, so now we have the most suitable area. So that is only area number 2. And I'll just for the sake of the coloring here, we'll keep that, we'll show that as being number 2. So this is not an awful lot of area, but that's okay. As I said, Swampy doesn't need a lot of space. Now at least we have more information on the shape area. And I already did it quickly, but you can click Sort Descending, and at the top you will get your largest areas. So we can go ahead and just select them as such, just by clicking in front of your object ID. Okay, so this is, according to our analysis, this is our largest area deemed suitable. Okay, now it could be that for your area you required a square space, or you require something that is larger than 36,000 square meters. Quite possible. So if this is insufficient, then we need to go back and select an area that has a suitability of a lower suitability. If we don't have enough space on our highest suitability, we could scale it down. So if your highest score is 8, but you only have, just as an example, 10 square meters of value 8, then naturally that's not good enough. So we go to suitability score 7 and see what the score or what the area sizes are for the suitability score 7. Now, for just the sake of this example, I want to select all the areas that are larger than 10,000 square meters. Okay, so that's, in this case, it's these top 3 areas. Now I can do this manually, but we don't like doing things manually. We like to model them so that we can alter them later on. So now that I have this information, I could do one of two things. I can either go in and add another select, but I would only put in information that I already have. Namely, I want larger than 10,000 square meters. So now that I know that, I could even alter this select. I can say I want Swampy Water suitability is score 2, and Swampy apologies, a shape area that is and we'll go larger than 10,000. Okay, verify again, double check that it's okay. So now it's going to select everything that is value 2 in suitability and larger than 10,000. So we don't want it to be or. In this case, it wouldn't matter, because if we would go, actually no, it would matter, because it would still look, it would go for either suitability score 2 or anything larger than 10,000. And that's not what we want. We want both. We want to be more selective here. This is the step where we become the most critical of our analyses. So here we go. Suitability score 2, area size larger than 10,000. We'll go ahead, run that, and if all goes well, there we go. We have 3 object IDs. We have 3 polygons left. Fantastic. There we go. 1, 2, 3. Okay, we can go ahead and sort descending again so that our largest area is on top. And this is our most suitable area based on our analyses and area size. Again, if this does not suit your area, if you need an area that is, for instance, if you come to the conclusion that you need to be close to the water, but your most suitable area is not near to the water, that's an issue. Then it could be that there's either an issue in your analysis somewhere along the way, so that you have to sort of trace your steps and find out where that might have gone wrong, or we come to the conclusion that, okay, somewhere in the analysis something's faulty, or the analysis, the inputs are all correct, but the output's just not as we expected it to be. It could be that somewhere along the highway, okay, that would be a big mistake, but somewhere along the highway, your most suitable area is found, but you need to be on the water. Okay, that's probably not going to happen. It's very, very unlikely. But if that is the case, then we will now do a validation step. Okay, so these areas here are nearest, or these are the most suitable areas, right? If we want to draw this up on a map, I would want to see what is actually there. So what I'm going to do is I'm going to go for Luchtfoto. Yeah, I want to have an aerial picture. And I want to see what's here. Because I want to do a little validation to see whether the area that I've now selected to be suitable is in fact suitable. Okay, we can go into the display and set transparency at, say, 50%. That'll probably do. So that allows us still to see the outline of our area. But look, so there's some issues here because according to our analyses, this should be the overlap of water and swamp. Now, if it's water, it can hardly be swamp. So there is a flaw in this analysis if we sort of look at the grand scheme of things. But just looking at this purely factional, we're sort of on the edge of the water in some areas, and apparently this is swamp. Is it really? That's debatable. I don't know. We could go into the field and we could actually verify this. We could take soil samples. We could check whether our feet get wet to determine whether it's water, yes or no. But this is the last step that we want to do. This is the other area here. Right. So Karen, this would be suitable for an alligator. I doubt it. I think the people in the harbor would have a bit of an issue with that. Okay. But besides this, the point that I'm trying to make here is that it's very important to select your top 3 areas based on both suitability score and required area size, but most of all, validate it. If your assignment is to find a suitable campsite and you do your validation and, oh, by gum, you've found that on the location where you want to build a campsite, there is already a campsite. Well, bravo, well done. Well done to either to them, because they've placed it in a highly suitable spot, and to you for finding that suitable spot based on your analyses. Okay? Same counts for windmills or solar meadows, or if you come to the conclusion that the location where you find your most suitable area is already filled in by that activity, I tip my hat to you. Well done. If it's not, that's okay. But it's well possible that in the time that this data was gathered and you've conducted your analyses, a house was built, or they've put in a road, or there's been a development of any other kind that would deem, if we relate this back to real life situation, that would deem your suitable area unsuitable. Okay, if that is the case, there you go. It's either a discussion point, or you can say, right, obviously this isn't suitable. We've validated it. It's not good enough. We're going to go back to the drawing board, see if we can find a different area that is also suitable, but perhaps just slightly smaller. Okay, that is up for you to decide, and that's up for you to describe and ultimately to defend in your decision-making process. Okay, right. Next step from here, make a nice map, show which area is the most suitable, so you can either highlight it with a number, or you can give it a different color, saying green is 1, yellow is 2, and red is number 3, as to indicate that you have sort of like your top 3 selection, which there's definitely one favorite to the other. That is completely up to you. I wish you the best of luck rounding this up. We will be available this afternoon for any questions and helping you up rounding up this assignment. Best of luck, and any questions, please don't hesitate to ask either on Teams, email, or when we're back physically in class. All right, bye-bye.